In this video of physics for class 11, we will be understanding about units and measurements. Physical quantities. All the quantities in terms of which laws of physics are described and whose measurement is necessary are called physical quantities. The process of measurement is basically a process of comparison. It involves the selection of a unit of measurement and comparing the quantity with the standard unit. The standard chosen should obviously be of the same nature as that of the quantity to be measured. For example, unit of length has to be in terms of length only. Similarly, unit of mass has to be in terms of mass, and so on. A physical quantity must be internationally accepted. Now let's see how a unit is defined. The chosen standard of measurement of a quantity which has essentially the same nature as that of quantity is called unit of quantity. Q equals Nu, where Q is the physical quantity, N represents numerical value, and U represents unit. There are two types of units: fundamental units and derived units. Fundamental units. The unit of measurement of length, mass, and time are called fundamental units. Derived units. The units of measurement of all other physical quantities which can be obtained from fundamental units are called derived units. For example, unit of velocity, force, etc. Now let's know about mass. Mass of a body is defined as a quantity of matter in the body which can never be zero. The mass of a body is not affected by the presence or absence of other bodies, or by the changes in location of a body. Now, there are two types of masses of a body. Firstly, inertial mass, and secondly, gravitational mass. Inertial mass of a body is a measure of inertia of the body, and gravitational mass of a body is a measure of gravitational pull of Earth on a body. The value of the two types of masses of body are identical. The most common unit of mass is kilogram. Originally, 1 kilogram was defined as the mass of 1 cubic decimeter of water at 4 degrees centigrade. Now let's know about the concept of length. The concept of length in physics is the concept of distance in our everyday life. Length of an object may be defined as the distance of separation between any two points at the extreme ends of the object. The most common unit of length is meter, which is represented by small m. 1 meter is defined as 1/10,000,000th of the distance from the North Pole to the equator of Earth. The General Conference of Weights and Measures modified the definition of meter in the year 1899. Now let's know about the concept of time. The concept of time is very old. The idea of passage of time occurred first from the motion of moon across the sky, then from the formation of day and night, and so on. Today, even a child is familiar with what time is, but it is very difficult to define time precisely. According to Einstein, time is what a clock reads. In fact, any phenomena that repeats itself regularly can serve as a measure of time. Human heart, which beats regularly, is an inbuilt clock in every human being. Rotation of Earth around its axis, revolution of Earth around the Sun are some of the examples of repetitive phenomena which serve as a measure of time. The most common unit of time is second. Originally, 1 second is defined as a time taken by a single pendulum of length 1 meter in going from one extreme position to the other extreme position. Later on, this definition was modified and 1 second represented 1 mean solar second. 1 mean solar day is made up of 24 hours, that is 86,400 seconds is the time interval between any two successive noons, that is the time interval between two successive passages of the sun across the meridian. Now, there are few choices of a standard unit. A standard unit should be of suitable size. A standard unit should be accurately defined. A standard unit should be easily accessible. A standard unit should be easily reproducible, that is, replicas of the unit should be available easily. A standard unit should not change with time and physical conditions like temperature, pressure, etc. Now, you'll be having a question about the person or the committee who decided the standard unit. So, General Conference on Weights and Measures is given the authority to decide the units by international agreement. It holds its meetings and any changes in standard units are communicated through the publications on the conference. Now, there are three main systems of units. The FPS system. The FPS system is the British engineering system of units, in which F stands for foot, P stands for pound, and S stands for second. The CGS system. The CGS system is the Gaussian system which uses C for centimeter, G for gram, and S for second. The MKS system. The MKS system is based on M for meter, K for kilogram, and S for second. The CGS and MKS systems are also called metric systems or decimal systems. Now, International System of Units. There are 7 fundamental units, or you can say base units: mass, length, time, temperature, electric current, luminous intensity, and quantity of matter. Kilogram is the unit of mass, which is represented by the symbol kg. Meter is the unit of length, which is represented by the symbol small m. Second is the unit of time, which is represented by the symbol small s. Kelvin is the unit of temperature, which is represented by capital K. Ampere is the unit of electric current, which is represented by the symbol capital A. Candela is the unit of luminous intensity, which is represented by the symbol small cd. Mole is the unit of quantity of matter, which is represented by the symbol MOL. Now there are 2 supplementary units. Radian is the unit of plane angle, which is represented by the symbol small rad. Then steradian is the unit of solid angle, which is represented by the symbol small sr. Few advantages of SI system are: it is a coherent system of units, that is, a system based on a certain set of fundamental units from which all derived units are obtained by multiplication or division without introducing numerical factors. It is a rational system of units, as it assigns only one unit to a particular physical quantity. For example, joule is the unit for all types of energy. This is not so in other system of units. For example, in MKS system, mechanical energy is in joule, heat energy is in calorie, and electrical energy is in watt hour. It is an absolute system of units, that is, there are no gravitational units on the system. The use of factor gravitation is thus eliminated. It is a metric system of units, that is, the multiples and submultiples of units are expressed as powers of 10. Now, some important practical units. Astronomical unit. It is represented by capital AU. It is the distance of the center of the Sun from the center of the Earth, and the value of astronomical unit is 1.5 into 10 raised to the power 11 meter. Light year. It is represented by small ly. It is the distance traveled by light in vacuum in 1 year. Speed of light in vacuum is 3 into 10 raised to the power 8 meter per second. So, 1 light year is 9.46 into 10 raised to the power 15 meter. Now, parsec. It is the radius of a circle at the center of which an arc 1 astronomical unit long subtends an angle of 1 second. 1 degree equals 3600 seconds. Then 1 second equals 1 by 3600 degree. The value of 1 parsec is 3.26 light year, that is 3.1 into 10 raised to the power 16 meter.